of energy and work. Just now we have derived a relation that work done is minus P external into delta V. Delta V is change in volume. If pressure is expressed in barometer and change in volume is expressed in dm cube, then the work has the unit barometer dm cube. Remember, this is not the SI unit, but it is the commonly used unit for work done. But we are more interested in SI unit of work. One barometer, we all know, it is equal to 10 raised to 5 Pascal, or it is equal to 10 raised to 5 kg per meter seconds per second square. One barometer dm cube can be written as 1 dm cube into 1 barometer. Now instead of 1 barometer, I will substitute 10 raised to 5 kg per meter per second square. So 1 dm cube barometer is equal to dm cube into 10 raised to 5 kg per meter per second square. But remember, what this pressure is in terms of meter and volume is in terms of dm cube. So this dm cube, now we will convert it into meter cube. And what do we get? 1 dm cube is equal to 10 raised to minus 3 meter cube. So instead of dm cube, we will write meter cube into 10 raised to minus 3. This 10 raised to 5 kg per meter per second square remains as it is. If you do the calculation, 10 raised to minus 3 into 10 raised to 5 becomes 10 raised to 2. Meter cube and per meter will get cancelled and meter cube will become meter square. So I will get 100 kg meter square per second square. But kg meter square per second square is nothing but joules. So 1 dm cube barometer is equal to 100 joules. So what is the commonly used unit? dm cube barometer. What is the SI unit? Joules. So what is the relation between commonly used unit and SI unit? 1 dm cube barometer is equal to 100 joules. Let us solve simple numericals based on pressure volume type of work. See the first numerical. 3 moles of an ideal gas are expanded isothermally from 15 dm cube to 20 dm cube at constant external pressure of 1.2 barometer. Estimate the amount of work in dm cube barometer and joules. So in this problem, the number of moles of an ideal gas is given, which is 3 moles. Children, to calculate pressure volume type of work, we do not need the number of moles. Even though when it is given, let us neglect the number of moles. Now the process carried out on the gas is expansion. So the final value of amount of work that you will get will be negative. Please remember this well. The expansion is carried out from 15 dm cube to 20 dm cube. Means 15 dm cube is the initial volume and 20 dm cube is the final volume. Expansion is carried out against constant external pressure. So P external is 1.2 barometer. First, you will calculate the amount of work in dm cube barometer and then convert that work into joules. See how you are going to solve this problem. So what is the data given in the problem? P external 1.2 barometer, initial pressure 15 dm cube, final pressure 20 dm cube. Though number of moles is given, I do not need number of moles. So even if it is given, it's okay. You need not think about it much. What I want to find out? I want to find out W in dm cube barometer and I want to find out W in joules. So this is the data and what is to be found out in the given problem. Now see the formula. Formula is W is equal to minus P external into bracket V2 minus V1. I'll do the substitution. Minus 1.2 into bracket V2 is 20 minus V1 is 15. So this will be equal to minus 1.2 into 5. This is 0. This is 6. So this will be equal to 6 dm cube barometer. So work done in dm cube barometer is 6 dm cube barometer, rather minus 6 dm cube barometer. Okay, now this dm cube barometer I have to convert it into joules. Just now we saw the relation 100 dm cube, 1 dm cube barometer is equal to 100 joules. So this I have to multiply it by 100. So minus 6 into 100. So this will be equal to minus 600 joules. So work done in joules will be minus 600 joules. A simple problem of 2 marks that can be asked in the board exam. See the second problem. The problem says that calculate the constant external pressure required to compress 2 moles of an ideal gas from a volume of 25 dm cube to 13 dm cube when the work obtained is 4862.4 joules. Now in this problem, the first statement itself says that you have to calculate constant external pressure, means we have to calculate the value of P external. The process carried out is compression. Remember, pressure can never be negative, so you should not get the final answer in negative. The number of moles of a gas is given. We do not require it, so let us neglect it. From volume of 25 dm cube, means this is the initial volume, that is 25 dm cube, to 13 dm cube, so final volume is 13 dm cube. So it is given that V1 is 25 dm cube and V2 is 13 dm cube. Work is given in terms of joules. See, the volume is given in terms of dm cube, work is given in terms of joules. So first I will have to convert this work which is given in joules in terms of dm cube barometer, and then use that in the formula to calculate the pressure, so that the pressure finally we will get it in barometer. See how to solve this problem. So now first let us write down what is the data given. The process is compression, so whatever work is given, it will have sign positive. Initial volume and final volume is given. What is the initial volume given? V1 is given to be 25 dm cube. What is final volume given? V2 is given to be 13 dm cube. The work done during the process is given to be 44,862.5 joules. Remember, work done is given in terms of joules. Volume is given in terms of dm cube. When volume is in terms of dm cube, the work has to be in terms of what? Dm cube barometer. So this joules, first I have to convert it into dm cube barometer. So what will I do? I will divide it by 100. So work will be equal to 4862.5 divided by 100. So shift the decimal points to the left. 48.625 dm cube barometer will be the work. Now work is in dm cube barometer, volume is in dm cube, so the pressure which I will get will be in terms of barometer only. This is the data and I want to calculate P external. Okay, now what is the basic formula? W is equal to minus P external into bracket V2 minus V1. Therefore let us substitute. W is 48.625 will be equal to minus P external into bracket 25, it will be 13 minus 25. So 48.625 will be equal to minus P external into minus 12. This minus sign will get cancelled. Therefore 48.625 will be equal to 12 into P external. Therefore P external will be equal to 48.625 divided by 12. A simple division. 12 4s are 48. 0. 12 5s are 60. 12 2s are 24. atmosphere. So the external pressure in this problem will be 4.052 atmosphere. Thank you. Please like, comment and subscribe for the further videos.